Okay, everybody, we are starting late, 7 minutes. Sorry about that. I will make it up. I will leave you late at the end of this lecture. So yesterday we talked about protected qualifier. What did I say? Protected is somewhere in between, actually. Private is really private, okay? If a function member or data member is in the private section, then nobody other than the class itself can access it, other than the class and the friends. And if it is something in the public section, either data members or the function members, everybody can access it. If something is in the protected section, that means that anything in the protected section behaves like public for the derived classes, but private for the outside world. Okay, so that's the rule. So as I said yesterday, some people don't like it. They say that, I mean, well, there is this public interface. Use the public interface for the derived classes. So there is no reason to violate this object-oriented programming rule of information hiding, etc. But protected is there. It is in Java too. Java took it in 1990s too. And that's how it was. That's how it is used and how it was invented. Okay, let's look at this redefinition thing again. Redefinition. Redefinition is, remember what we did with the, okay, this one, no, well, these are different. Let me try to open this employee age or employee, okay, and salary employee, this salary the employee, and okay, good. So what did we say? We said that employee age has a print check function, but I really cannot implement it very well because I don't know how much to pay to a person. Okay, I have the net pay, but is it weekly, it is hourly, it is something, I don't know. Okay, so when I implement this print check, in this case I said that, well, I am going to give you another message, but the correct thing would have been maybe, let me try to open the employee age, employee CPP. I don't have the, sorry, I don't have the correct implementation of it. Anyways, I implemented it this way. I don't know how to implement it, so I am terminating my program for the employee ages print check. But when I derive my salary the employee class from the employee class, now I know how to do it. Okay. By the way, it was like this, right? So from 42 to let's not. Okay. So it is like this. So I don't know how employee behaves, and I'm going to implement it this way. This is called redefining. Okay. This is very different from overloading. Okay, this is called redefining. Okay, redefinition. Redefinition basically means that implementing the function again with the same signature. And it is very different from overloading, very different. Okay, redefining in derived class, okay, the same parameter list, same signature. Overloading is with a different parameter list, with a different signature, you define the function with the same name. Okay, when you redefine it, you ignore, okay, or your intention is to not use the old definition. With the overloading, all definitions are still there and I'm using it. I am adding a new meaning. Okay, I am not changing the meaning, I am adding a new meaning. Here I am changing the meaning of the function. That's the difference between redefinition and overloading. Of course, for redefinition, you need inheritance. There should be a base class, then the derived class, right? For overloading, you don't need any hierarchies, class hierarchies. It is straightforward function overloading. We talked about this function signature, functions name, sequence of types, and parameter list. The book says, I think it is not in the book, but in the slides. The signature does not include return type, which is correct. It does not include the return type, but the const keyword and the references are included in the signature too. Okay, if you write two functions, let's write it. Let's see. Yeah, compiler explain. I'm going to show you. Okay, let's get rid of these. Okay, a function f, I don't know what it does. Oh, okay, that's my problem. Okay, so return 1. Let's see if it takes like a integer I. Okay, so it just, I'm not going to optimize anything. It is doing funny stuff. Okay, so what does it say? It says underscore, can I make this larger? Yes, I can. Yeah, the produce, too large. The produce function name is underscore z1fi. We don't know the meaning of it, right? But it looks like f is the name of the function, I is the integer it takes, underscore z1 is the returned type. Let me make this a double. Well, see, it is not reflected in the signature. But if I make this a const integer, is it the same thing? How about this one? How about this one? Okay, it is RKI. Okay, so the difference between this one and this one is Control Z, is there, right? So one of them is a reference, the other one is a not reference. The signature changes, the name of the function changes. Let's try to compile this. So it says that compilation failed. Why? Because I'm trying to define two functions with the exact same signature. But if I do this, they will compile, right? How about this and that? Well, I mean, with the const keyword here, it did not compile it. But remember what we did with the index operator. Remember, we defined two index operators. One is a const index operator. The other one is not a const index operator. In that case, I can do it. I can define the same function with different const. One of them is a const function. The other one is not a const function. So what I'm saying is that these two statements are not true. This is definitely not true, and most of the time this is not true. But this is definitely true. The signature does not include that. Okay, why are we talking about signature? Because we are trying to compare redefining redefinition versus the overloading. Overloading says that use a different signature. Redefinition says that use exactly the same signature. Okay, use exactly the same signature. Okay, I'm going to skip this one because I will have an example. Okay, so let's talk about this. Functions not inherited. As I said, and I put a quotation sign between around this statement, functions not inherited. There are no functions that are not inherited. Everything is inherited, including the private data members and private functions. Okay, and the book says that there are some exceptions, functions not inherited. For example, constructors, destructors, copy constructors, and assignment operators. Again, these are inherited, but they don't become your constructor, destructors, copy constructors, or assignment operators, okay? They are inherited and they are accessible, but they don't become automatically your constructors and destructors. The thing is different in case of, let's say, for the employee age, I directly get name, SSN, get net pay, get set name, etc. I directly inherit them from the employee class, okay? And they become my functions automatically. But these two constructors are inherited, they are available, and I have to call them, right? See, I am calling it in my constructor, salaried employee. But the employee's constructor doesn't become my constructor. Or employee's assignment operator doesn't become my assignment operator. Remember my favorite class? Okay. Remember my favorite class? Class A. Okay. We said that for this one, there is a default constructor, there is a default copy constructor, default assignment operator, and the destructor, right? Okay. These four things are default. These four things are default. And when you say class B, public A, very simple hierarchy. Class B inherits everything from class A, but class A doesn't have anything. Well, that's not true. Class A has defined four functions: constructor, destructor, assignment, and copy constructor. All of them are inherited, but class B has its own default functions: constructor, copy constructor, and etc. Okay, and when we write class B's constructor, as we did in this example, we call the base class as constructor because we know that it knows how to initialize it. And for the assignment operator, we are going to do the same thing. For the destructor is a little bit different. Because there is only a single destructor, we don't need to call it. It is called automatically. It will be called automatically. Okay, so let's see one example from the book. It's a nice example. Remember our PFLED class? PFLED, partial field array. Remember this one? Partial field array, no parameter constructor, and a constructor with the integer parameter. Okay, and copy constructor is there. Add element is full. Get capacity, get number used. Empty array, index operator. Remember I repeated this index operator with the const sign. And the assignment operator and destructor. These are all nice stuff. These are all nice stuff. And in my, see, I made it protected. It looks like I'm going to derive a new class out of this PFLED. And it looks like I'm going to access them directly, right? So protected, and it's exactly the same. I like this class a lot, but I like to add a new capability to it, okay, without modifying this class. I am not going to modify this class. This class will say exactly the same. It will not know that somebody is deriving from it, okay, and I will make a new class, and that new class name will be PFLED Backup. A PFLED class that can take the backup of itself. So let me show you an example usage. Okay. Integer capacity. I got the capacity from the keyboard, and see PFLED Backup A cap as expected. Well, PFLED Backup is really a PFLED class. There is a relationship, but it has something more in it. Okay, so the constructor is the same. With this capacity, I made a new PFLED Backup object, and I added elements until my array is full or the user entered something negative. Okay, so I did that. Okay, this is a nice check. If it's a there is no space left or you enter the negative number thing, then I said how many elements I have here. Okay, get number used. Okay, I printed all of them, get number used. Okay, from 0 to get number used here. One by one I printed them using this nice index operator. I use that too. Then I do this. Okay, I take a backup. Backup is not something that we had in the PFLED class, but it is something that we have added to a PFLED backup. After I taking the backup, I just save the data somewhere in my object. Then I emptied the class. I emptied the object. Remember how the empty array worked? It just says that I have 0 elements in my space. Okay, and when I call this one line 66, it's going to return what? It's going to print 0, exactly. This one will print all the elements in my array. This one will print 0 because I emptied the array, but I have a backup of it. And since I have a backup of it, I can restore it. I restored my array. Now, when I say a.get number used, it will be non-zero because I brought them back from a backup space and I print them out, and that will be it. So this PFLED backup is going to be a very simple in terms of how we use it. It is no more complicated than PFLED. It just adds 2 functions to it: empty the backup and the restore. Yeah, that will be it. But since there are lots of pointers involved, since the base classes constructor, copy constructor, assignment operator, destructor, etc., they don't become my functions. The pointers are involved. Big tree is needed. Then I need to implement all of them. That's what makes it kind of complicated in terms of implementation. Okay, so let's look at the implementation of PFLED backup. Okay, any questions? Any questions up to this point? If somebody asks a question today that the first time question askers, I am going to give you this: Turkish Antarctic expedition. It has historical value because we don't go to Antarctica every day, right? Yeah. See what you are missing, guys. Really. And I have other stuff too. I don't know what I have. This is probably junk, yeah. Yeah, this is nice. See? First time question askers. So what is this? USB, yeah, nice. What should I do? I am not going to give you this one. No, this is nice. This is keychain stuff. How many can I do that? Okay, any questions? First time? No, I remember you. But no. Maybe I shouldn't be that unfair to my favorite question asker people. I am going to reserve this to a first time question asker, but for the others, if I like your question, I am going to give you this. Okay.
When we deal with backup,
Where is Abdurrahman? I am not going to give him anything. Yeah.
when we deal with backup function, what are we gonna do when we also deal with dynamic arrays?
Well, that's the question. Yeah. Did you ask the same kind of question during the exam too? I don't know how to solve this question during the exam. Somebody is asking me, I don't know how to do this. That's the meaning of exam. Yeah. Yeah. So the question is, how are we going to do this? Yeah. Let's design it. So if I have a PFLED class like this, a double pointer capacity used Okay. When I take the backup of it, right? When I take the backup of this double array pointed by A with this capacity, with this used, I should have some other space to store all this information, right? So the answer is what? You tell me. So, yeah,
I don't know. I asked.
I'm asking back to you. I mean, the solution is there, right? I mean, what do we do to keep a number of doubles in the memory? I dynamically allocate space and I keep a pointer to it. Now I have additional space for my backup, right? So what are we going to do? Back to you. Yeah.
Can I pass?
No. The answer is in, it's just there. Okay, anybody else?
We can allocate the memory for a class of object of this class, and we can copy it.
Allocate more memory.
Allocate memory.
Memory for doubles like this one. And when I take the backup, I just copy them to that position, right? Okay, congratulations. Okay, it's yours. Check for the viruses, okay? I don't know the company. Okay, so this is what we are going to do. PFLED backup, okay? It will have a double pointer, B, and it will have how many elements of it used or capacity of it, an integer. And for the functions, I will have a constructor, of course, copy constructor, assignment operator destructor, and on top of it, I will have restore and backup. This will be just enough, right? Okay, so this is the whole hierarchy, whole PFLED and PFLED backup hierarchy. PFLED backup is a complicated class, but when you build yourself on top of this one, it becomes kind of easy, right? So let's see the implementation. Let's see the implementation. First, PFLED backup header. Where is my, PFLED backup header is here. I am deriving myself from PFLED. Okay. Constructor, copy constructor, backup and restore. Should they be const? Should they be const? No, why? Because both of them are modifying it. I have the assignment operator and I have the destructor. Index operator, get size, empty array, add element. I don't neither redefine them nor modify them. Okay, well, I don't redefine them. I don't include them in my header. And this is what I have now. Double pointer B and int use B. Okay. Question. In the PFLED, okay, I had used and capacity. How come I don't have the second integer here? I have used B, okay. I don't have the capacity. How come I don't have it?
We can already reach it because it's protected.
No. What I'm saying is that I have 3 data members in the base class. Since I am going to take the backup, it looks like I am going to take backup of double array. I am going to take the backup of used integer. How about the capacity? I am not going to take the backup of capacity.
Use will be the net capacity.
How about the used then? What am I going to do with the used?
Do we even need it? Because we can allocate for only used memory.
Yeah, because I mean, that's exactly the same thing. Because I am not going to add any elements to the end of this double array B. It is my backup. Once I take the backup, it is fixed size. I am not going to change its size, right? With the PFLED, it is different. There is used numbers, used side of the used portion of the array, and the capacity of the array. This one is, well, I mean, maybe I don't like this. Well, I mean, it could have been both named use or capacity. I think capacity would have been a better name, but anyways, they called it use, and I'm going to use code. Yes.
I think if we remember the capacity as well, it would be better for performance.
No.
And we take another backup, we have to
Resize it?
yeah.
It takes a second backup. Well, when we look at the implementation, we are going to say it. Okay? And the other thing is that, remember, this is the PFLED that doesn't dynamically change its size. There is a fixed capacity at the beginning. Remember that one? Book implements it that way. I don't know why they didn't implement the nice way of real dynamic class. So I think for this case, this is good enough. And they could have done it that way, but by doing it this way, they are kind of showing the distinction between a backup of a thing and the thing itself. Okay, so let's look at
In line 20,
You are not a first-time question asker, right? Okay.
I want to ask. In line 26, const ampersand right side. Why do we use const and ampersand at the same time? Does the const keyword also copy the original value when we call the operator?
I don't understand. What do you mean? I mean, what is our rule for any function? If you are passing an object, non-fundamental type object, you pass it by reference. To prevent any accidental changes, you pass it by constant references.
So we make sure that it's not copied. We get the original value, right?
Yeah.
But the const also assures that we don't change the value. So why does it copy it if we don't use ampersand?
Why are we? Well, the ampersand means that it's called by value, called by reference, and it is not copied. It is efficient, right?
Yes, but what if we don't use it? It's copied, right? If we don't use ampersand.
Well, I mean, you are confused about the meaning of this assignment operator and the meaning of this constant. This doesn't have to be an assignment operator. Wouldn't you write a function like this?
Normal function, and
Yeah.
if we don't use ampersand, does it still call by value?
Yeah.
Then why does it? We don't change the value, so it doesn't need to be.
Oh, you mean? Okay, you are saying this.
Yes.
Why don't we do this, right?
Copy. I mean,
When you say I am going to take a parameter, a constant, I promise that I am not going to modify it. You are saying that why doesn't the compiler optimize in a way that it doesn't take the copy? We don't know. Maybe the compiler is doing that. I don't know. Maybe compiler is doing that.
well, I tried it and.
It takes the copy?
No.
It doesn't take the copy.
Yeah, the address remained the same.
No. How do you know that it doesn't take the copy? Did you overload? Did you implement the copy constructor and make sure that the copy constructor is not called?
No, I just did like I sent the parameter without ampersand, and I took the reference. I printed the reference, and the reference was same in the main function and in the function also.
Well, I mean, you cannot modify this right side object if your parameter is like this. If you modify it, compiler will give you an error. Okay? Your question is, as I understand, if it is not changeable, why are we taking a copy of it? Because this is called by value. You asked for it. If you didn't want the copy to be made, then pass a reference.
So I tried it and it didn't take the copy.
How do you know that it didn't take the copy?
I printed the address of the variable that I sent, and it was the same. was in the same place.
Oh, you printed the address set of it. So did you use any optimization flags?
No.
It was just -01. Yeah. So compiler optimized it then. But it didn't have to. Okay. For some compilers, maybe GCC is a smart compiler, and it might think that it is doing such and such and etc. But it didn't have to take a cover. But by the way, there are some. Remember, how do we take a copy of an object using the copy constructor, right? If I write a copy constructor that takes special copy of the objects, for example, I am ignoring some part of the class. I have 4 data members. When I take the copy, I only copy 2 of them, and the rest of them I am ignoring it. In that case, taking a copy is different, right? Let's say I am trying to count the number of objects that I have created. This should definitely create a new object. The C++ rule says it, right? So in that case, not making a copy would confuse the programmer. So sometimes the compilers, they try to be smart. Sometimes they can mess the things up. For that, there are many switches in GCC saying that don't optimize these don't take shortcuts with these kind of situations. So that's a good test, and that's a good question. You guys understand the question, right? The question is, I mean, if this is const, I mean, everybody knows that I am not going to change it. Why doesn't the compiler just use the same copy? Why does it make a copy of a const parameter, right? That's the thing. Yeah. Well, by the way, for doubles and integers and that kind of stuff, well, copying the object and sending a reference is the same cost. In that case, it will make a copy whatever you do. Okay? Good. So let me change this back to original. Go back to our discussion. Let's implement this. So it's going to look like this. Right? And if I am sure I had drawn. No, I did not. Yeah. PFLED looks like this. Okay. In a PFLED backup objects looks like this. Inside it, there is this PFLED part. It has used, it has capacity, it has a double pointer. And in PFLED backup object, there is USB and a double pointer. Okay? It will look like this. When I take a backup of my array, whatever this double points to, okay, it will be copied from this location to that location when you take the backup. When you restore it, all these values will be copied from backup to the original position. This is what the whole thing is going to look like. Okay? So dynamically, there is some space for me to add elements to, okay, which is pointed by A. And when I take the backup, these values are copied there, right? But when I take the restore, when I do the restore, I move these values back to this original location. So let's go back to our code and see how it works. PFLED backup CPP. Okay. So maybe I should show you just to remind you how PFLED works. Let's look at PFLED as the base class. Nice. My IO stream, I'm going to use this one. PFLEDH, I included. My no parameter constructor capacity is 50. And you remember this, right? And this is the second constructor. I think this would have been like this much better, right? and don't implement this at all. Comment it, right? Is that, no? Is that, yeah, this is exactly the same thing, right? If I give you the parameter, then use it. Otherwise, if I don't give you the argument, then take it as 50, right? So use it that way. And this is my copy constructor. Remember, I need to implement big 3 in this case. I take another object. And that other object is constant reference. First, I copy the capacity of it to myself, and I copy the get number used of it to myself. Capacity and use are done. And there is this third element, A. A will be assigned to this pointer, a newly allocated double array. And I get the other objects, PFLED A objects, A values, A double values to my A double values. So I am copying them one by one. Index operator is like this. Check the validity of the index. If it is greater than or equal to use, terminate it. Otherwise, return this one as a reference. Okay, assignment operator. If my capacity is not the right side capacity, delete my array and get some new space. This will automatically handle A assignment A cases. Remember, if I assign the same object to the object itself, my object assignment my object. In that case, deleting my A, my dynamically allocated space is dangerous, right? So I am checking this. If the capacities are the same, my capacity and the right side capacity is the same, don't do this deletion and new allocation thing. I have enough space. If it is not, then I delete my space. The other side should be different than myself, right? Then get the space, get the new space, capacity used, and do this one by one, copying it. And return this so that I can use cascaded assignment operators. Okay, and this structure is simply this one. Add element, it's not dynamic. We didn't like it, but I think it was like 5-10 lines of code maybe to make it dynamic. Get rid of this larger than the capacity thing. Okay, this one says that if it is greater than capacity, I don't have space. Okay, if it is not, then I just do it this way. Yes?
If we use vectors instead of arrays, when we want to resize the vectors, would the backup change or would it be error?
This one doesn't know anything about backup, right? We didn't talk about the backup yet. This one is the base class. It doesn't know who is going to derive from this one. So ask that question when we implement backup. We don't usually, okay, think about what the derived classes are going to do when we design the base classes. Okay, usually. If we are designing them together, yeah, we think about them. But in this case, it's just simple dynamic array, double dynamic array that does that. Okay, so don't forget about that question and ask it when we discuss the PFLED backup. If I like it, I'm going to give you this. I have. This one is nice too. Never use pen. Is this a software company? Yeah. Really? Oh, there's a notebook too. Okay, so full is this. If capacity is the same as used, then I'm full. Get capacity is this. I mean, I don't like it. I'm going to change it. If this is this one, so what am I going to do? Tell me. Definitely a new double array. Okay, an array new double and new double. Okay, so remember what we did? capacity times 2, I am allocating some new space, right? Then for integer I from 0 to use or capacity, same thing, right? Okay, I less than, okay, I less than used and plus I. So tell me, what am I gonna write here? NA I guess the value of AI, right? So I did that, so then what? Then what? Well, I think I should do this. A should point to whatever NA is pointing to, right? NA is pointing to my new space. A is pointing to my old space. Well, no, I am in trouble now. Since A is pointing to this new space, nobody is pointing to my old space, and this is what memory leak, right? This is bad. So what am I gonna do? You have a question?
I will answer.
You have a question?
Before assign to NA, we should delete.
Yeah, you guys are saying the same thing. So, pens for you. Catch it. And close your eyes. Other people, close. Okay. So, delete A, right? And do this thing. A gets the value of NA. And we forgot to increase our capacity, right? Is that correct? Yeah. Well, let me behave like a, right? You didn't like it, but you know what's going on, right? I am both making capacity. I shouldn't do this because I am thinking about it, right? I mean, is that correct? I mean, doing this and that. I mean, don't try to write short code, okay? Write explicitly understandable code. But because I am lazy here, I'm both doing the assignment, capacity assignment, and making a new double of the new size and etc. Okay, then I do the use, and so we have a completely dynamic. We have a completely dynamic stuff. Use is not going to change because since use is the same as the capacity, I did that. Our capacity is increased. Yeah, that's good. Yeah.
Can you use destructor for deleting?
No. You will never call destructors explicitly. Destructors are called by the compiler's code, okay? If you delete the whole object is deleted. Not just A, right? Your capacity, your used, okay? Any other thing that you don't know about in your object, they all will be deleted. That's a bad thing. Don't do that, okay? Yes?
In the assignment operator, we return the reference this, but its return type is PFLED reference. How does it work?
So you're not talking about this add element, you are talking about this assignment. So you are saying that if I don't return the reference this, I return what?
It returns PFLED reference, but we return the reference this. How does it work?
Well, I am returning a reference to myself. I know my address. I dereference it. I get a reference to myself. And I'm returning a reference to my object.
This is a reference to.
This is not a reference. This is a pointer.
What's the difference then?
What?
What's the difference then? Reference and point. In reference and point.
Pointer is an address. Okay, we know it. References is a concept that I cannot tell you in assembly, in terms of assembly, this and this. Under the hood, yeah, it is implemented using pointers. But reference is something, when you say it's a reference to the original object, I mean, we semantically, we understand that right side is the same name to the given argument. Right side is the same name as the given argument. That's what we understand. If you are trying to understand what's going on with the assembly version, well, of course, it is implemented using pointers. Under the hood, it is equivalent to pointers, but in C++ syntax, it is very different than pointers. Okay? Any other questions? You look confused. Just address your confusion. Just catch it. Close your eyes. Okay? Did that help? You are not confused anymore.
Can we see the previous part?
You are not the first time question asker, right? You ask. Okay. Can you do what?
Can we see the previous part?
Can I do what?
Can we see the previous part?
What do you mean previous part? The up, page up?
This column.
Which function?
We made A equal NA, A points NA.
Oh, you mean the unmodified version?
Add element.
Yes.
Add element function.
Dynamic allocation of other.
Well, I did the dynamic allocation here. I don't know what you want to see. Go.
The capacity part.
Doubling the capacity.
Doubling the capacity?
No, increasing the capacity part.
Yes, it is.
Okay. You mean the add element? You want to see the function add element?
Yes. I didn't.
Why didn't you say so? Okay.
I didn't see this function name.
Okay.
Now we made a space for NA, then we copied the variables, then we deleted A and we did A equals A points NA.
Yeah.
But what happened to NA?
NA is a local variable.
Then
It will be deleted. I mean, it's just an address. It's just let's say, okay, let's draw the figure. Okay, let's say, where am I going to do that? Okay, let's say this is my original, in my memory, PFLED object, right? There is this A field, use field, and the capacity. A points to some place in my memory. It has this many elements, right? Now I did this. I said that add element, and this is not enough anymore to me. I need to increase the capacity. So what I am doing here is, let me make this a little bit larger. Okay. I am saying that I need a new space for my object to point to, because this space is not enough. Let's remember what we did. We said that at the beginning, I am going to make a new array of size 2 times the capacity. So first I have a local variable named NA, and I allocated the space. This is 2 times as large as this one. NA is pointing to this location now, right? After I copied my elements one by one, okay, to this location, after that, what did we do? We said that now I am going to delete A. A will be deleted, so this will be gone, but A is still pointing to this location, dangling reference. But then, what did I say? A is not going to be pointing to that location anymore. It will point to whatever NA is pointing to, right? So A is pointing to this location. Then, when that scope is gone, at this point, NA will go away, okay? NA is going away doesn't mean that the place that is pointed is going away because NA is just a local variable here. A is my data member. It's not going away because it belongs to this function, right? This object. Or capacity doesn't go anywhere. Use is not going anywhere. But NA is going to die. But it is okay since I take the copy of it and I deleted my old one. That will be it. Okay, good. Any other questions? What? Can we get a break? Of course, yeah, that's a good question. And here's your... Yeah. Okay, I got this. Okay. Oh, who did I give my pen to? But I think that pen belongs to that one. Can I have it? Really? Yeah. Your question wasn't good anyway. I mean, yeah. Thank you. So it is even better, even though I break somebody's heart, it was worth it. Okay, 10 minutes.
Base class'ı construct'a çağırmamız gerekiyor mu? İnheritediğimiz class'ta. İnheritediğimiz class'ta base class'ı construct'a çağırmamız gerekiyor mu?
Sen çağırmazsan o kendisi no parametre constructor'ını çağırır ve başına belaya sokabilir.
Yani bunu ne zaman yapmam lazım? Mesela pointer varsa işin içinde ya da...
Her zaman yapman lazım. Konuşmadın mı geçen sefer?
Her zaman yapmam lazım ama hani...
Adı ne onun arkadaşın? Hamza Hoca. Hamza o defter tamam mı? Yazı yazıyorsun. Arkadaşlar o defter ya tanımıyorsunuz değil mi siz? Öbürü de kalemdi. Kalemi yazıyorsunuz içine.
Hocam 4 yıllık kitap almadan bitirdim.
Şöyle bir şey sorayım. Biz direkt dediğimizde port 2 verilerin sildiğine emin miyiz?
Delete hiçbir şey silmiyor ki. Sadece ona sana ait değil diyor. Orası jump bekliyor. Yani oraya şu pointer'la tekrar düşmeye çalışsan büyük ihtimalle ne varsa onlardan
Evet öyle.
büyük ihtimalle.
Bazen
her zaman değil ama.
Bazen oluyor bazen olmuyor.
Bazen de crash olacak.
Ben biraz geç kaldığım için sonra olmuş. Yani yakalayamadım o partiyi. PFLED
Bunları
Backup'ta...
daha önceden anlattım ben ya.
Yok. PFLED Backup'ta içi setter getir yok dedik galiba.
He?
PFLED Backup klasının içinde setter getir yok dedik galiba. Yani görmedim
Hayır,
ben.
öyle bir şey demedim ben. PFLED backup'ın içerisinde get
Görmedim
number
ben.
of elements, get capacity, işte
Onlar
get... Onlar yok çünkü onların hepsi inherit olmuş zaten.
Tamam. Yani şey ama
Sen
yine
bugün
de...
geç kalmamışsın. Dün ve evvelsi gün uyumuşsun.
Yok hocam görmedim ben orada da. Sonra parti kaçırdığım için soramadım o yüzden.
Yok zaten olmaması lazım.
Peki şeyi soracaktım. İçindeki diğer elementler için yani kendi klasının içindeki private'lar için setter getirleri olmak zorunda ama değil mi?
Hayır. Güzel bir soru. Bunu derste sorsana.
Tamam.
Eğer hoşuma da giderse sana bunu vereceğim. Sorun.
Hocam şey çektim.
Ya da sana şunları vereyim gitsin yani.
2 boyutlu şey
Rocker
tutarsak,
switch kontrol ünitesi.
şey yaparsa hocam, şimdi dinamik olarak 2 boyutlu bir array tutarsam ben, onu diyelim ki döndüreceğim şimdi. Index operatör yapacağım. Diyelim
Şuraya işte. Hareket etmiş. Tecrüben olacak. Ya şöyle hareket yap. Simit ne lan? Simit mi? Fakir misin lan? Oğlum o kadar 15 milyar maaşın var. Ay. Her kaç bin lira kazanırsın işinde? 30 milyar. 40 milyar var mı? Tamam. Simit güzel mi lan? Biraz 50 milyar.
Evet.
50 milyon.
Biraz ver kanka.
Tamam 100 milyon.
5'te 1'ini versen yeter.
Nasıl yazıyor ya?
Kaç para? Niye ucuz o kadar? Ucuz.
SKS bile.
Hadi gitme.
Ne oldu?
Versen kaç para?
Reis yapma hayır.
Yok şu an çok erken ya.
Yapma.
Olmaz.
Abi ne yapalım?
Bundan falan olacak. Kanka bir şey verecek. First time değil mi?
Bunlar da kaybeden
First
Afrika'dan.
question, first. Aynen şey değil.
Mağdur şimdi soru ben sorayım. İkisi beraber.
Kalem aldı ama. Ben var ya derse girmem abi de.
Abi benim gözüm çok şey oldu ya.
Senin yerinde olsam derse girmem bile.
Harbi ha. Çok özleyeceğim.
Kanka söylemeseydin lan bu kalem burada diye. Öyle mi diyeyim? Ha.
Bence defter hak ettiydi ama işte. Diğerleri kalem oldu. Ben sıkıntıyı biliyorum, sıkıntıyı biliyorum. Yanında oturması.
Beraber misin?
Böyle şöyle yazalım. Bir de böyle yapayım. Böyle sallanacak.
Nasıl aktivim burada ya? İngiltere nasıl etkiliyor? Oğlum
Kalem istedim.
tamam bundan anlıyorum. İngiltere nasıl etkiliyor?
Ben benim için aldım.
Ha doğru.
İşim var. Oğlum verirler ya. Şeyde ben hocam.
Aynen çok güzel.
Tamam.
5'te başladı değil mi?
Seninle başlarsın.
Ne zaman istersin?
Hani bir daha
Evet
soru
gel
falan
şunu
sor.
yenmemi lazım. Gel ya gel.
Bak onu
Şöyle çalışıyorum bak şöyle gideceğim.
onu ileri götür kazanacağım. İnanman lazım bunlara.
Kendini al yeter.
Kendine inanman lazım.
Başarmanın tek sırrı parmakta. Biraz daha var.
Var mısın?
İngiltere'de bir bakma.
İngiltere batmaz.
Benim batmaz orada.
İngiltere batmaz.
Kaç? İyi. Güzel. Hı? Ali'yi öldür kanka. Niye yarışıyorsun? Ali'yi boğdan. Bir saniye. Uyan.
Geliyor.
Yani saat almak ne ya? Saçmalama ya. Ne saat alıyorsun ya? Hı?
Doğru diyor. En zor efsane şey. Hocam.
Kasıyor lan. Çok saatler var.
Kasıyor mu kasıyor? Yaparız ya. Var değil mi? Bize kanka sen İngilizce diyor muydun? Ya bari
İngilizce konuştu ya. Ben de şaşırdım.
Sesler geliyor. Ne oluyor?
Dedim yabancı biri mi gibisin? Ya boş yapma.
Yanında Elon Musk var.
Abla şimdi sinirli.
Elon Musk. Elon Musk koşuyor.
Elon Musk babam yapıyor.
Geçmiş olsun. Kardeş nasılsınız?
Yazıyorlar da atlayamıyorum. Elon Musk'a.
Sharing IP68 command line
'Benim canım sıkılmış. Bir daha sana yaramadım.
Buraya saat var. Buraya nasıl saat var? Ne de yakın.
Geri al kanka. Hakkın oldu.
Verirsin.
Sen niye geri ver? Ben mal geri ver.
İyi hadi kabul etmiyoruz.
Bab olmadığını bilseydim gelmiyordum ben.
Ben zaten yok yazmamı istiyoruz.
Tamam yok yazıldı.
İkinci ders yazdım.
Erken geldi. Yazılmayı unutmayın.
Yapmayın abi.
Ben boydum mu dedim?
Yok. Kuşları sonra.
Herhalde kaldı yanındayım.
Ama da kalmaz. Ha, kalırsa bu adam kalır.
Kaç saat sen şu an? Şu an hiç bilmiyorum.
Takip etmiyor bu adam. Takip edince azalıyor mu? Var ben ya. Güzel miyim kanka?
Duymaz yani.
Tamam oğlum.
Ya korktum.
Olsun. O zaman da ben o yüzden
Soru soracak mısın? Daha önceden soru sordun mu sen hiç? Sormadın. Sormadın. Bak bunlardan var. Bunlar da soru sordurmuyorsa daha ne yapabilirim ben bilmiyorum. Kalemlik herhalde ya. Kafa karıştıran kalemlik.
Bir yerde uyanıp su içip
yanlış yapmışlar.
Hocam bir şey söyleyebilir miyim? Ben ilk derste bir 15 dakika geç kaldım da yok mu?
Tamam, hayır. İlgilendiğiniz için teşekkürler. Yok mu yazılı? Okay, so let's go to our PFLED backup class. Okay, let's start implementing it. It has a no parameter constructor, copy constructor, assignment operator, destructor. Big three is definitely needed. We have some pointers going on. Deep copying is needed. Shallow copying is going to hurt us. It's going to cause some weird behavior and sometimes crashes. So we need to do this big three. And backup and restore is why we are doing this class, right? Take a backup and restore it. Okay. Start from the constructor. Let's do the constructor. Why don't I start writing the constructor myself, right? This is the backup. Let me take it out. Okay. So to write the constructor, of course, I need the name of the class. I need the constructor itself, okay? So how did it work again? I think I have two constructors. One is the no parameter constructor. The other one is a constructor that takes an integer. But I am going to do this again. Capacity 50, right? Okay. And then do this. What am I going to do? I will call the constructor of the base class, PFLED, and I will feed this capacity to that one. So the base class is double pointer A, integer used, and integer capacity is done now, right? I handled it. Then I have two other data members here. One is a double B, the other one is use B. Okay? One is a double B, the other one is use B. So what am I going to do with this? How am I going to initialize those? How am I going to initialize them? Where is, oh, this is not the correct, okay, here it is. What should the use be? What should be the B be? Okay. Well, it depends on your implementation choice. I think at the beginning, let's not allocate any space for the. I'm not sure if the book did it this way, but I'm going to do it this way. At the beginning, I am not going to allocate any space for the backup because if I don't take any backups, right, that space will be wasted. So I'm not going to take any space for backup. I am going to do this. Used B is 0, right? And then was it B? PFLED backup. Yeah, B. And B is null PTR. Okay, let me make this like that so that it fits and empty. Okay, good. Like it? Say yes. Okay, good. So that's the constructor again. That's my plan. My plan is I am going to take the backup of my PFLED whenever it is required. So, I mean, the alternative would have been allocate space for B as big as cap, right? That's what the That's what the PFLED, right? Okay, PFLED here it says that at the beginning, I allocate some space for the capacity, right? This is what it does in the constructor, and I call this one. It sets the size and the use and etc. But I am going to do the other way. I'm going to say that, okay, since I am not taking any backups right now, okay, I am not going to allocate any space for B. I am not going to waste it. Because for this object, if nobody takes any backups for the lifetime of it, so I will be efficient in terms of memory usage now. Okay, so what else? I am going to write the copy constructor. Let's write the copy constructor. Copy constructor would need another constant PFLED backup object, right? And other. Okay, good. So, well, I think I should do this, right? Okay. So, PFLED, what? What am I going to send it? This one, I send the capacity. This one, I am going to send what? I am going to send, well, other is, what is the type of other? Backup. But PFLED expects, just hold on a minute. You're not going to talk, okay? I don't like you. I like you. But for 5 minutes, you're not going to talk. PFLED constructor expects a PFLED object. Now I am going to send a PFLED backup. Does this compile? If it doesn't, what am I going to do? Let's handle the others. PFLED other and what? And my used B is other dot use B. No, this is not definite. That's bad. No, I need to make deep copy of it, right? So let's. Okay. So question is this: is this going to compile? This one expects a PFLED, right? I mean, that's what the copy constructor of the PFLED does, right? It expects a PFLED, but my other is a PFLED backup object. Okay, anybody answering this right is going to get this one with all kinds of goodies in it. It can even do this. Oh, yeah. Doesn't do that. Don't do that. It hurts. Oh, okay. Do it and that like that. Okay. See? It kind of works too. So, not you. No, I don't like you either. I don't like you either. Yeah. Somebody new. You. Do you think it's funny? So you are going to answer it, yeah? So why? The hint for you, this is not a compiler, it works. Because of what? Because of what principle?
I don't know.
That's not the right answer.
Can you give me the first letter?
Because of what?
Can you give me the first letter?
I. It is not edible. It doesn't have any colors. It's an abstract concept. How can I do that? It doesn't give me a compiler and it works. But PFLED expects a PFLED copy constructor expects a PFLED object. I am sending a PFLED backup project and it works.
PFLED backup not implemented.
What?
Not implemented.
Well, I'm implementing it. This is the copy constructor of the PFLED backup.
But it's in inner PFLED.
PFLED copy constructor is implemented, of course. It is this. PFLED copy constructor is this, and it works nicely. We tested it. No problems. Now I am implementing this PFLED backup.
Due to there is a relation.
What?
Due to there is a relation.
What relation?
Yeah, inheritance.
Is a relation, right? That's why the first letter is I. Because it is a relation, right? Because there is a relationship between PFLED backup and PFLED, right? What did I say? And you are not listening to me. I said that the compiler knows that. The compiler knows that. Okay, there is a relationship between PFLED and PFLED backup. Okay, so compiler knows that every PFLED backup object is actually a PFLED object. Why? Because it is in it, right? For every PFLED backup, there is a PFLED in it. Every PFLED backup object can function, can behave like a PFLED object, right? That's why I can do it. And that's the reason why I keep saying that compiler knows about this relationship. Okay? This one works. If it didn't work, then I was in trouble. I had to say other dot something, other dot the PFLED part of this thing, or that would have been like a weird thing, right? Okay, so this part will handle the PFLED part of the PFLED backup object. Now I have two things to do. The other one is, I guess, the other one is, okay, it's yours. I don't know why I didn't give you, who else raised their hands? I didn't like you and didn't like you, who else? Okay, you are going to give me this answer, right? Is a relationship? How about you? Okay, you take that one. Okay, give him this. And that too. I know I need this one.
Okay.
Okay. I am going to. So I have two things. Arctic expedition. Oh, it is not Arctic expedition. This is Antarctic. It is even better. I thought it is Arctic. Yeah. Good. So maybe I should keep this. So I am going to do the other part. The other one is use B, right? So use B should be same as other dot use B, right? Okay. So use B is same as other dot use B. So the thing is that now I need to allocate space for my B and copy whatever the others B is to my location. So tell me, what am I going to do? Okay, what am I going to type? What am I going to type? What? A new double, yeah. Did you ask any questions before? Did you? Oh, really? What's your name? Atakan. Congratulations, Atakan. Okay. Don't stay too long in there because that's cold. Okay, new double. So it is how easy it is to say something in the class. I don't know why you guys don't talk. New double, then Atakan, tell me what I'm going to write in here.
Capacity.
Capacity or use B, right? I mean, or capacity is the same as maybe use B. No. It's not capacity. It is going to be. It's going to be use B, because if I do the use B, I know exactly how much memory I need for capacity. Is for the capacity of the PFLED, right? The capacity and USB might be two different things, depending on how many times you take the backup, how many times you reallocate it, and stuff too. So what am I going to do on the left-hand side of this assignment operator? What? Yeah, exactly. Okay, since you really talk, and this is yours. Give this to her. And I am done. Then nobody has to ask any questions anymore. Unless you want this bag. Okay, so B new double, and then what am I gonna do? In a loop, right? Integer I from 0 to I less than what use B, right? And plus I what B I gets what? Other dot. Is this okay? Is this okay? Is this okay? Other I? That would be a bad thing. That would be a bad thing, right? I am copying the original values of PFLED to my backup space. That would be a bad thing. So the right thing is this, right? How about this? This is a bad thing, but does this compile? Does this compile? Can I access the data member A of PFLED? Yes or no?
Is it private?
Is it private?
Yes.
No. It's not private. It's what? Protected. Okay, that's the good question. If it is private, we can't. It is protected, yes, we can, but we should not do that. That's a bad thing, right? We should do exactly this. Okay, then delete something, right? Delete what? Delete what? B? No, B is our thing. Okay, delete other B?
No.
No? Did I confuse you? Copy constructor this one is. We are not going to delete anything. Yeah. If you delete other.b, then you are going to leave B in an unstable state, dangling reference, right? That poor guy is in trouble after you are done with it. Okay, so we are not going to delete anybody. Okay, good. So this is how you write the copy constructor. Okay, so yeah.
Can you explain line 15?
15?
Yes.
Let's go to line 9. What does line 9 do? Okay, I am going to make a new object, PFLED backup object, but I know that I am a PFLED object too. So who is going to initialize my PFLED part? Base classes constructor using this, right? The rest of them I will do it easily, no problems, right? The same thing here. I am copying myself from some other PFLED backup object. So there are two things to be done. The first thing is for the PFLED part, somebody is to copy these parts, okay? So I am going to call the base classes copy constructor to handle this part, okay? This part has to be copied. Use has to be copied. Capacity has to be copied. This double pointer has to be copied in a deep way, not shallow way, okay? So the base classes copy constructor does that anyway, okay? So I am just calling it. For the USB, I am just using the others USB. I have to do some other stuff like who is going to make this copy? Who's going to make, okay? Who is going to copy the other objects backup values to my object? Of course I'm going to do it because nobody knows about that. That's what the line 15 does, and line 15 and 17, 18, 19. Okay? Any other questions? Good, let's continue. What else we should do? Okay, I write the no parameter constructor and a single parameter constructor, and I write the copy constructor. Now I'm going to write Destructors, let's write the destructors. No, I'm going to write the destructor because destructor is this. Simply delete this B. Well, who's going to delete then A, right, remember? Well, base class's destructor is going to delete it, but you don't call it like the constructors. It is called automatically. Base class's destructor is not called by you. Remember, you should never call the destructors explicitly. They will be called automatically, okay? Before this line executes, or I'm going to talk about it, okay, the order about it, okay? After I deleted this one, the base class's destructor will be called and it will be deleted properly, okay? But I am handling only the part that belongs to me. I don't care about the base classes, dynamically allocated space, and etc. Okay.
Can you open PFLED?
PFLED header implementation. What? Header?
I have some implementation.
Implementation. Yeah.
I have something about constructor.
Constructor. Okay, this one.
Not copy.
Copy constructor. Okay.
In the main, can we, while we call this copy constructor, can we send parameter of this PFLED back object?
PFLED backup. That's a very good question. Since I think you are coming from this location, okay? Since I can send a PFLED backup to this one, can I do just the opposite? Can I to this copy constructor, can I send a PFLED backup object? Okay, back to you guys. That's a good question. Can I do the opposite? Okay.
Isn't it to say we are sending PFLED constructor to PFLED backup object?
Yeah, well, yeah, that's exactly, yeah. You are. I thought you are asking this one. Can I send a PFLED to this one? Are you trying to ask that question? We are already doing that, yeah. I thought he's asking this. We are already doing that already, right? We did that here. Here we did that, okay? PFLED copy constructor, we send a backup object to it. Because every PFLED backup object is an PFLED object, right? The answer is yes. I thought you are asking just just what?
How can we do it? Other is more complicated than PFLED.
Other is more complicated, but inside the other, there is PFLED, right? So the compiler kind of ignores this part and only uses this part, right? Understand? Your trouble is PFLED backup is much more complicated object than a PFLED backup. PFLED backup, which is this one, is much more complicated than simple PFLED. How can I send such complicated object to? But there is a relationship between them. Compiler knows this part of the PFLED backup, okay, is exactly same as PFLED, right? So the compiler knows how to ignore this part and treat this object as a PFLED object. That's why we call it is a relationship. Okay? That's why we call it is a relationship. Anything that a PFLED can do, PFLED backup can do too, right? It is complicated, but on top of it complicated. It is the same as that one. On top of it, there are other stuff. Okay, just the question that I misunderstood. Can I do the opposite? Can I send a PFLED object to this copy constructor? The answer is no. Is a relationship is not symmetric, okay? PFLED backup is a PFLED, but PFLED is not necessarily a PFLED backup. I am not saying is not, okay? Is not necessarily, because some of the PFLED objects are PFLED backup objects, but not all of them. Okay?
How we set and get variables of PFLED back?
So which file are you talking about? What file?
PFLED back.
PFLED backup header?
Getter or setter.
Oh, okay. That's a good question. I think you asked this during the break. The question is this. The question is this. Yeah, that's a good question, but I don't have anything to give you. So I don't want to take away. I know that guy didn't like it, but I don't want to take away anything from other people. So the question is this. How come I don't have any getters and setters for this one? And maybe I can ask you a question about how come you didn't ask me the same question for these. Do I have a setter for AA in PFLED? Answer is no. Do I have a setter for capacity or used? No, right? Should I have a setter for, well, it looks like I have getter for capacity, getter for used, but I don't have setters for those, right? How come? Well, what was the rule? Make all of your data private, right? And then write setters and getters for all of your data. Now I have get capacity, get number used, but I don't have set capacity, set number used. How would you implement? Well, implementing get capacity is very simple. Return capacity. Implementing get number used is return used. How would you write a set capacity? Capacity assigned the given number. How would you write the setter for the used? Used assigned the given number. Can I do it? I can implement it very easily, but does that make sense? The answer is a very, very big no. No, you shouldn't write them like that. Because if I set used to some random number that the user is giving me, what's going to happen to my allocated space? Okay, I messed up everything, right? That's not, and for the capacity too, okay? I know that there are 3 meaningful numbers in my array, and I'm going to let somebody change the use value to 15, for example, but I know that there are 3 used elements in my array, but my use became 15 now, okay? So rest of the array is going to be junk numbers if I have enough space on my memory, if I am lucky. If I am not lucky, I'm going to get a crash, I'm going to get a segmentation fault. So the rule is not always write getters and setters for all of your data members. That's something that many people do all the time. I don't know why. No, the rule is write setters and getters or any function if it is needed by the user, if it is useful, it is meaningful for your class. I don't have any setters or getters for this AA, right? I don't have it. Okay? So, you shouldn't write it, by the way. I mean, there should not be any setter for AA. Okay? There should not be any getters for AA. Setter is more dangerous. That will mess up my internal class workings. Okay? Setter is more dangerous. Getter will expose your data to outside world. They can modify it before you know it. That would be a bad thing. Okay, good. Okay, let's go back to our PFLED backup. Let's implement a few more. We have implemented constructor, copy constructor. This structure I showed you. Let's implement the assignment operator. You have a question? Yes.
What about some other dot cap in the PFLED?
Other dot capacity?
Yes.
Well, other dot capacity does not belong to me. It belongs to the base class, right? And base classes, everything is copied by this one. This one, see, this is the copy constructor of the base class. Base class's copy constructor copied the capacity, copied the used, did the allocation, did the copying of all the base classes data, and I am fine with it. I don't think about them. Base class is handled. All I think is the new things. The new things are the double pointer B and the used B, integer used B. I handle those two. Okay, let's write the assignment operator. Let's write the assignment operator. Assignment operator is going to return a reference to this PFLED backup, and then this one operator as operator assignment, and it will take a constant reference other, right? And yeah, again, I should definitely use the base classes assignment operator, right? Definitely use the base classes assignment operator. I should definitely call it. So how am I going to do that? Let's do that, okay? How am I going to call the base classes assignment operator? Well, when I say operator assignment and O, well, it looks weird, but it should work, right? What operator is this? This operator, this one? Well, this is an infinite recursion. That's not good. What am I going to do? This one was easy. I said the name of it, and it called, yeah.
PFLED scope resolution.
Yeah, exactly. Do it this way. What did I do? Okay. Operator assignment. Okay. So I am calling the base classes operator assignment, but base classes operator assignment expects a PFLED object. I am sending a PFLED backup object to it. There is a relationship, it will work. So this one will handle the double pointer A, use and capacity thing. So rest, I am going to do it now, okay? So rest, I am going to do it now. How am I going to do it? Let's delete our space first. Okay, delete B, right? Then B is going to get new double other dot use B, right? Then after that, I think I am going to just do exactly the same thing here. Should we be careful about, okay, BI is other BI. Yeah, good. Well, it looks like this is exactly the same as that one. Should I be careful about doing self-assignment thing? If the other side is same as me, then don't do that. Let's do it at the beginning, right? If this is not equal to address of other, then do this. Okay, good. And at the end, return what? Return what? The reference, this, right? Okay. So if somebody is not doing self-assignment, then I call the base class assignment operator that will handle the base class part. Then I delete my double pointer B. I get some new space. By the way, this is not that, but this. Okay, I think I found it. Okay. I get my new double, and after that I iterate over all the numbers and I put them in back in. Good. So this is the assignment operator. Any questions? What else do I have? I need to take a backup. Let's write the backup. Let's write the backup. Right, okay. So backup returns what? What does the backup return? It is void. Yeah, both of them are void. Backup is void. Void. And backup doesn't do anything. Okay, what am I gonna do now?
Allocate new space and copy.
What?
Allocate new space and copy.
Allocate space. Should I deallocate my old space? Do I have old space? How do I know that I have old space? Well, I know it because if I did not have any old space before, I know that it is null PTR, right? I was smart there, right? I did this. If my old space is just null PTR, if my use B is 0, that means that I don't have any space to deallocate, then I don't deallocate. If it is not 0, then I should deallocate my B and allocate new space and copy everything. So let's do that. Okay? Let's do that. If B is not equal to null PTR, right? Then do this, what? Delete B. Good. I don't need these. I think I'm going to do this. Because I am not sure. I mean, doing the debugging, it should be, if B is not null PTR, then I should do this. Assert, what? Tell me what I'm going to do. If B is not null PTR, then what? Used B, what? Should not be, while I'm looking for the equal sign, yeah. It should not be 0, right? If B is not null PTR, use B should not be 0. If it is 0, then there is something wrong, right? Because I only keep the array B if there is something to take a backup of. If there is nothing to take a backup of, then it should be 0. If it is not, I am going to get a assertion fault, and I'm going to fix it later. Okay, now let's do this. Allocate some space. B gets new double. Yeah, what? Used is something not meaningful. Get. Does that make sense? Get number used, right? Is that correct? Get number used. Get number used is a base classes function I inherited. I can use it directly. Get number used is my new B, right? And then do this copying. From some place to some place. Okay, from 0 to what? It's from 0 to get number used. right? From 0 to get number used. Well, in fact, I could have used what? Use, right? Directly used. Yeah. So you meant used by used. You meant this, right? Not use B. Okay. So you were right. Sorry. So this is, let's say it is used because that's protected. I can use it. Used, and BI is other dot. BI is what? What am I going to write here? BI is definitely there is no such thing as other. BI is what? BI is AI. Good. What is A? A is my PFLED's double pointer. BI is my backup space. I am going to copy the used amount of it, used number of it, to my backup space. Okay? And now my used B should be, maybe I should do it here, right? My used B should be same as used. Okay? Are there any classes after this one? Do you know it? Anybody waiting outside? Okay, so this is our backup. And how about our restore? Restore is, question for you. Am I going to delete anything in my restore?
Our backup.
Why?
It's gonna be memory.
Why am I going to delete it?
I don't have to, but
We don't have to, then I am not going to delete it. Maybe somebody is going to restore it more than one times, right? Yeah. So I think for the restore it's going to be a simple copying. Well, maybe I'm not sure about that, because if I am not sure, but maybe I should delete my A, right? Because my backup is going to be different than, right? So I'm going to delete my A for the restore. Do it yourself, okay? On Monday I'm going to see you. I think we will finish up this chapter then. Write this class yourself. Write this class yourself. Ne yapacak mıyım? Neyi? Ya bunun zaten şeyi yok mu o kitaptaki hikayeleri?
Kendi yazdınız.
Kontrol. Videoları var ya. Videodan bak. İyi, tamam.